This video is on the objective. Calculate a confidence interval for a population mean with the population standard deviation unknown. Right? Sigma is unknown here. So we're working with the student's t distribution, right? T scores instead of the standard normal z scores. But this is with the calculator. Right? This is the objective that's specifically calculator-based, calculator instructions, the TI 8384. And this is the second one, number 2. So I've already done a video on this objective. Here's just another question related to this objective from your Newton-Alta homework. So it'll be a bit quicker. I'll just show you where to go again to find the function you need to run to find a confidence interval for the mean with the calculator. Alright, so again, if you're unfamiliar with this, you want to see how to do it on the calculator, see what instructions they give you, click on more instruction. But I'm just going to do it. All right, so suppose here that the length of unemployment for laid-off workers is normally distributed with an unknown mean and unknown standard deviation. A random sample of 33 unemployed workers is taken and gives a sample mean of 90 days. Right, so that's your average length of unemployment for these 33 people before securing a new job, and a sample standard deviation of 10 days. So that's n is 33, x bar, the sample mean is 90, and s, the sample standard deviation is 10. So use a calculator to find a 90% confidence interval estimate for the population mean. You're using the student's t-distribution. Round your final answers to 2 decimal places. So again, I'm just going to pull the calculator up right now. All right, so remember to do a confidence interval for a mean, to estimate a population mean, when you don't know sigma, right, when you don't know the population standard deviation, you're going to go second, go to the distributions area. I'm sorry, not second. Sorry. Quit that. Go stat. Apologies. Hit the stat button. Go over to tests. And then if you recall from section 8.1, remember z interval was for a population mean when you know sigma, when sigma is known. Right below it, number 8, t interval is for estimating a population mean when sigma is unknown. So I enter on this. Now it's going to ask you, do you have a list of data or just statistics? Looking at the problem, right, they didn't give me a list of data. They didn't give me all 33 of those workers, unemployment times, unemployment lengths. So they just gave me stats. So it's flashing on stats right now, and then you just go below and enter the appropriate information. What was x bar? What was the mean for that sample? It was 90 days. So 90. What was S, right? SX, what was the sample standard deviation? That was 10 days. That was given to us as well. What was N? What was the sample size? There were 33 workers, 33. And what's the confidence level? Now you got to enter the confidence level as a decimal. All right, so it's they said 90% confidence interval here. So 0.9, right? 0.9, 0.90. Again, don't enter 90. It's got to be a decimal. And then calculate, and there you go. The lower value, remember this would be the x bar minus the margin of error, 87.051. And then x bar plus the margin of error, 92.949. There's our 90% confidence interval. So we'd say that we're 90% confident that the population mean, right, the average length of unemployment for all laid off workers is somewhere between 87 days and 92 days, almost 93 days. All right, so I'm going to enter these values, and they asked us to round these final answers here to 2 decimal places. So that lower value, 87.051, that would round to 87.05. So that's what I'll enter. And the upper value there was 92.949, which would round to 92.95. 0.95. Alright, let's submit and see what happens. And it's really, again, that quick and easy using the t-interval function there. and entering the proper statistics and the proper confidence level. That's it. All right, so again, hopefully this was quick and easy. Helps you out when you're doing this kind of problem on your own. And thank you very much for watching.